So welcome back. This is Joel, and in this video, we'll be actually talking about BGP, right? So the agenda is going to be we'll be discussing some of the most important pieces of BGP with respect to the BGP characteristics, implementations. We'll talk about the advanced features as well, and then probably end the session with attributes, right? Probably all of this would be spread across a couple of videos. Okay, a very basic topology over here, which we probably will be using for the discussion, right? Now to start with, before we even delve into this, we need to understand why BGP, right? Why do we even use BGP, right? Probably I'll use my whiteboard here. So till now we have studied about a lot of IGP protocols, right? So this is where all of this fits in. So you have your you have an AS, right? Generally you have an autonomous system here, you have another autonomous system over here, right? And inside the autonomous system, we know we use ISIS, right? We know we use OSPF and so on, right? eIGRP and all of that. Now what protocol is used to connect these both ASs, right? Now that's where your BGP comes in, right? So this is like a unique use case for unique use case, and this is where you use your border gateway protocol BGP, right? Now you would have heard about different kinds of BGP, right? The eBGP and the other one being the iBGP, right? The former is the exterior BGP protocol, and the second one or the latter one is the interior BGP protocol, right? So let's discuss why do we even want this, right? So we understand now that eBGP is needed to exchange routes between autonomous systems, right? So let's start with putting up a very basic topology of a let's say of a a service provider network, right? This is how it looks. So we will basically have probably use like black here for this. So let's say we have an autonomous system here, right? We have an autonomous system and we call this autonomous system 100. Cool. We have another autonomous system here, and let's call this autonomous system as 200, right? And the other one being we have the last one over here, which is AS 300. Okay, cool. So now let's say we have routers here, right? We have the provider edge routers. Let's say we have a we have probably B over here, and on this let's say we have two provider edge, one is C and the other one being your D, and E is the internal router, right? And all of these are connected this way, A to B, B to D, D to E, C, and like this, right? Now which are my provider edge routers? Probably I can highlight it. This is my provider edge A, B, D, and C, right? Whereas E is my obviously interior gateway protocol, right? So interior protocol doesn't have BGP running on it. So the eBGP will be running on A, will be running on B, will be running on my C and D, right? And on the E, basically inside this autonomous system, probably there'll be an IGP running, maybe like an OSPF and stuff like that, right? Cool. So till now we have just discussed about eBGP, right? So now we are basically trying to understand why do you even want iBGP, right? So on the to recap, on all my provider edge we'll have the eBGP running, right? And my provider edge is basically A, B, C, and D. Okay. Now let's assume there's a route. There's a route, say 1.0, right? .0.0. So this route is there, right? And this route is basically on A, right? Because of eBGP, this route will reach my B, right? Understood. Because BGP is there between these both, eBGP to be more specific, this route will reach B. Now when in BGP, the interesting thing is when routes are shared, along with that some attributes are also shared, right? For this discussion, let me limit it only to a couple of attributes, which is one is the next hop, right? Next hop in this case, let's say it is going to be A, right? For the route 1.0.0, when it is reaching B, the next hop is going to be A, right? Because to reach 1. You need to take the next hop as A. and the AS path, right? AS path is another attribute. Let me call it as AS path here. So the AS path is going to be 100 over here. So what is AS path? AS path is basically used for tracking the ASs through which the route is passing. In this case, the route has come from 100, so the AS path will be 100. Now the same route, when it comes to D over here, right, the next stop changes. It changes to B. The next stop becomes B, whereas what does AS path become? The AS path becomes, you will still have 100, right? The AS path gets prepended because now the route has passed through AS 200 as well, right? So it becomes 200 comma 100, correct? So the AS path is changed here. Now next, let's assume that the same route moves from A to C as well, right? So on C, what will we have the next stop as? It will be A, and my AS path will be just 100, right, because it is coming from A, right? So now what has happened? We have two provider edge routers, right, and they have the route to the same we have the route to the same network. Both C and D have the route, but at the same time they have two different ways to get there. C can directly go here, whereas D will have to go to B and then it will have to go to A, right? Two routes. Now how do we talk between the routing protocols? Like I already told you, inside the AS we'll generally have a iBGP running. So let's say we have like an OSPF running over here inside this. So if this BGP has to talk to my OSPF, right, I'll have to redistribute, right? Now in this case here we have two ways of redistributing. Either we can redistribute via the, because you have two different paths to the same route, you can redistribute telling that okay, maybe take C as the C as your path, or maybe take D as your path, right? But ideally I would have taken C because it has the shortest AS path, right? It's just one hop away, whereas if I'm going via D, I'll have to go first to B and then go to A, right? Now the problem with redistribution is that when you redistribute, right, any protocol, you're losing the metrics, or you're losing the attributes in this case, right? In this case you'll basically lose the attributes, which is your next hop and AS path. So when you redistribute, say, this BGP route into my, say, OSPF, you're losing this amazing benefits which you're getting out of next hop, right? Now using the next hop, you would have easily predicted which is your best path, but because you don't have the attributes anymore, once you're redistributed, you don't have the attributes, right? So OSPF will basically see two different routes to C and D, right? And it will basically say, let's say, we forcefully redistributed BGP into OSPF by making my C as the best path. Let me highlight this, right? Let's say we redistributed by saying my C is the best path. So to reach 1.0, now E will basically take this way, right? E will take this particular path. Now in this case it works, right, because obviously this is the shortest path to reach 1.0, so it looks good. Now let's assume that we added a new route behind 2, right? Let's say we added, say, 2.0.0, right? Tomorrow we added a new path or new route behind B, right? But because we have already redistributed through C, even to reach 2.0.0 we will still take this path like this, right? Now isn't this right bad? Because to reach 2.0, actually the D was a better option, right? So you understand what I'm getting at. What has happened now is, because we redistributed the BGP into an IGP like OSPF, we kind of lost all the amazing benefits of BGP, which is the attributes, right? The AS path to start with, we basically lost it. Now because we lost the AS path, we we basically lose a lot of benefits. Now that is the reason why we kind of use iBGP inside the AS domain, right? So generally in a design you will have you will have an iBGP for routing like OSPF or ISS, but at the same time, right, you will have an IGP for routing, but at the same time you will also have an iBGP as well, right? When you have an iBGP inside the AS, it helps you to retain the AS attributes, right? So it helps you retain. So what would have happened is that if we had iBGP here, right, inside this AS300, when the routes were when the routes were being learnt on C and D, right, those attributes would have been retained when the routes were moving on to my router E, right. As a result, you don't have all these complications getting created, right. So that is the main reason of using your iBGP, right. Let me delete this. Yeah. So that is the most important reason of using iBGP, that we can actually retain all the attributes which we learn via eBGP, inside my AS, right. Great. So another example, another use case of using iBGP I could also tell is with respect to preventing routing loops, right. So I can take a similar example. Let me probably drop another AS here. Let's say I have an AS, right. I have an AS here. Let's call this AS 100, right. I have probably couple of let's say we have a router here which is A as usual, right. Let's say we have another probably AS here, and we also have another AS here, right. And this AS is basically, let's say 400, and this one is 500, right. And on the edge you have routers like F, you have routers like G over here, right. And behind my A, let's say like earlier, I have my route 1.0.0. Okay. So now when this route, right, this route from A first goes to F, it comes here, right, and the AS path is going to be 100, right. When the route comes here, the AS path is going to be 100 because it was learned from there. Now the same route, when it goes to G, right, when it comes here, the AS path is going to be 400 and 100 because it has passed through two of the ASs now, right. When this same route again goes back into the originating AS, the AS path is going to be 500, 400 and 100, right. This is what it is. Now this is BGP uses a um, route loop kind of avoidance mechanism by using AS path, right. So when a particular AS or when a particular router sees its own AS in the routing update like this, right, it is seeing what it is seeing 100 here, right. It is seeing 100. So because it is seeing 100, it knows that this route was originated from myself, so it will not accept this route, instead it will drop it. So this is how we prevent a routing loop, right. So which means that this AS path is really useful for me, right. If this AS path is transported through the routing, if it is currently transported throughout, right, it is of really great value to me because I will prevent routing loops as well, right. But let's imagine, like in my earlier case, we did not have iBGP, right. Let's say some one of this domain, let's say this particular domain did not have iBGP. Because there was no iBGP, right, you would have basically ended up losing the whole AS path information, right. You would have lost the AS path information. So when this route would have redistributed or would have gone inside the other domain over here, we would no more have the AS path, right, and we would have lost on all the benefits of my AS path mechanism. So this is just couple of attributes. There are other attributes, and there are a lot of advantages of those attributes as well, and that is why we go for iBGP inside the autonomous system, so that we don't lose out on any of the benefits of the attributes. So iBGP is majorly used only for is majorly used only for retaining the attributes, right. It doesn't do the routing. It is not used for routing. For routing, you will still have some IGP like your OSPF or ISS running inside my AS. All right. So let's actually go back to my topology which we have, right. And what we could do is we could probably try configuring some of it, right. Let me go back to here, right. So I have this topology here. So what we'll do is let's start by configuring. So let's say where do we start with, right. We'll start with R5, right. We have R5 over here, right. So let's see, where is my should be here, right? So this is my R5. It's just here. Cool. So yeah, great. How do we configure, right? Very basic. Let's start with show IP interface brief, right? We have this is how I have configured my IP addresses in my network, right? I'm using 192.1.xy, where x is the smaller number and y is the bigger number, right? So between R5 and R2 it is going to be 25, right? Very simple notation I'm using to configure the IP addresses, right? Couple of loopbacks, right? Loopback 0 will have a mask of subnet mask of /8, and this is of /24, right? I've used that way. Now starting with how do you do this? What we'll do is we'll go to router BGP, right? We'll have to give an autonomous system for R5. Let's give it as 500. The network, you need to advertise the network. So we'll advertise the Phi network, right? For Phi network, I can use 5.0.0. In BGP, you need to be very specific of the subnet mask, right? Exactly. So in this case, because my loopback 0 has a subnet mask of /8, I can directly do this, right? Because because it's a class A network, /8 is the default mask, so I can use this. But whereas if you see loopback 1, I have actually used /24 while configuring this, so I can't blindly just do this. This won't work, right? This won't work. So I have to explicitly be more specific here. Because I've used /24, I need to define my network this way, right? So I will use 255.0. There you go. So I basically ended up setting up BGP on my R5 now, right? I can do show IP BGP. So BGP internally, this is not the routing table. BGP has its own topology table, right? And where basically you'll have the best routes, the feasible routes, and everything, right, put up over that. So this is my internal BGP table which you're seeing right now, right? So I just enabled BGP on these two networks, but did I set up a neighbor relationship? In BGP you need to set up a neighbor relationships, only then you'll have all the neighborship forming, right? So now between R5 I need to create one with R2, right? So what will I do is I will go to my R2. Before going to R2, I can do it here, right? I'll create neighbor, and what is my R2? 192.1.25.2, right? And you need to mention the remote AS, right? Remote AS, it's going to be R2 is present inside 1000, so remote AS is 1000, right? Now let's go to my R2 and configure this. So let's say I do show IP interface brief, okay? And what else? We go and put router BGP 1000 network command, and you need to use 2.0.0, and the other one is, like I said, I have done 22.22.22.0, and the mask is gonna be 255.0. Makes sense? Neighbor command, very important. Neighbor command, right? I have to do it this way: 192.1.25.5, which is my R5, right? As for the diagram, that is what I'm trying to do. Sorry, remote AS. What is a remote AS? It is 500, isn't it? There you go. Now the BGP neighborship will start forming, right? You can see here the neighborship came up. So now I can do show IP BGP, right? If I do this, I'll see my topology table, and you can see the R5 route is visible now, right? The network 5 and 55 are learned from R5, and that's visible now, right? Some interesting things to see here is that let's say uh, you can see here there's something called path, right? And this is basically what I was talking earlier, the AS path. The AS path attribute is basically helping you to understand from which AS did this route come from. So for 5 you have the AS path as 500, right? Whereas the route which originated on R2, for that you don't have an AS path, right? But there is also a tag which is saying I over here. What does this mean, right? So this I basically stands for what you call as the origin code, right? And if the route was injected into BGP using the network command, just like how we did it over here, right, it would always show it as a I route. Okay, if the route was injected using, let's say, redistribution from some other protocol, in that case you will have a question mark here. We will see that as well in future, right? Obviously, when deciding if you have like two different routes to the same network, then obviously the I will take more precedence over the question mark. Okay, great. Now we can also look at the routing table, right? This is basically, this is not the routing table, like I said, this is just the BGP table, and we have enabled it between R2 and R5, eBGP basically what we have enabled. Now if you want to see, let's say on R5 I want to see my routing tables, I can do show IP route, right? Or maybe make it very specific to BGP, it's going to be this one, right? So you can see the 2 route and the 22 route are visible, and they have a tag of B because they were learned via BGP, right? Now we'll continue this same thing, and we will do this now on R1 and R4, right here. Let's do the same thing on R1 and R4. So let's go to R1, enable show IP interface brief, configure router BGP. It's on R1, so it is 1000. Network, what network? 1.0. The other one is network 11.0. Mask is important, right? And the neighbor command is important, 192.1.14.4, right? Remote AS is going to be 400. Make sense? Same thing, let's go and do it on R4 now. Enable show IP interface brief, right? Hit the configure section, router BGP. We are inside 4, so it is 400, right? And what else? So we gotta put the network command, which is 4 dot, right? Put the network command again for 44. Mask is 255, right? And the neighbor command is important. The neighbor command is 192.1.14.1. Remote AS is 1000. Make sense? Because we are doing it between R4 and R1. Okay, now the neighborship should come up anytime soon, right? It's up. So I can show you the routes. Do show IP route BGP here, and you will see the routes which are learned, right? Do the 1 and 11 network are seen, right? We can also look into the BGP table. Do show IP BGP, right? This is not the routing table, this is just the BGP topology table, right? You can see the one network is there, it has a AS path of 1000, whereas these both are the locally connected routes. Okay, great. We did R4, R1. What do we do next? Let's also finish off the R7, right? Let's do the R7. So for doing the R7, we will have to establish neighborships between what? We will have to establish with the R1 and R4 as well, right? So let's do that first. Let's do it on maybe R1. So on R1, the only one statement which I'll have to put it is the neighbor command, but instead we will have to do this on 47 here, because it is 4 and 7, right? So no, my bad, wait. So we'll have to do this on which one? 17, my bad. So we'll have to do this on 17, 17.7, right? And the 700 is the AS, and we did it in along this direction, right? We will also do it this along this direction as well, which is R4. On R4, let's do it so let's do this on 47.7, and the remote AS is 700, right? Good. So we have done. Now we just need to do it on R7. So on R7, it's going to be enable show IP interface brief, right? Configure router BGP 700 networks. What networks? So on R7 we have the 7 network, and you also have the 77 network. Good. Once we have done that, now we have to establish the neighborship, don't we? Would be neighbor 192.1.17.1, right? Remote AS would be 1000, and the other one is 47.4 because it is R4, and the remote AS will be 400. There you go. In a second, even the other one should come up. Right? So it has come up. Good. So if I do something like show IP BGP, if I do show IP BGP, we'll be basically able to see the BGP table now. You can see you have the 1 network, you have the 4 network. Both are being learned over here. Right? Great. Actually, let me also show you another way of doing the same thing. Right? Just now, I mean, till now we have been using the network command and the neighbor command, right? But what if you want to enable, if someone tells you, can you enable BGP without using the network command? There is a way to do that. So what I'll do is, let me actually go and remove these 2 commands, right? This was the network command which I used. Let me do a no over here, right? Let me also do a no for the other network, right? This one, right? It's gone, right? So I've removed these 2 networks, which means if I do, right, you no longer have the 7 networks in the topology table. Now I'll show you a different way to do this, right? How do you do this is, you can first create an access list. Let's go back. Let's create an access list, a very simple access list, permit with a permit statement. What are the 2 networks we want? 7.0, and the mask is going to be 0.255, 255, 255, right? Great. The other one is going to be 77, 77, 77, and 77. Cool. And the mask is going to be just right this one, because this is /20. The first one is /8. This is /24. That's why the masks are different. There you go. We have created a route access list. Now we'll create what you call as a route map, right? Route map. Let's say redistributing, connected routes, right? Let's say RC. Anything. The route map name can be anything, right? A match statement. What addresses do you want to match? The ones by this access list. So it's 1. Right, now you go inside my router BGP, which I have already defined, right? 700 GP 700, and inside this I will go and redistribute connected routes route map, and the name of the route map is RC. Right, by doing this I have eliminated the use of the network statement, right? Because this should still give me the same thing. Show IP BGP, you do see, you can see my 7 and 77 network, but the only difference is that you can see for 7 network you don't have a I over here, you have a question mark here, right? Even for 77 network, you can see here I have a question mark. So I wanted to show you this difference, so that's why I did this way, right? So if a route is learned in BGP via say redistribution, then you will have a question mark mentioned here. If it is learned via the network statement, then you will have a I over here, right? Makes sense. Next. Right, so that's good. um, what do we do next? Okay, so there is another thing which I can show you here is that, let's say you want to manually override this, right? This is how the default behavior behaves, but let's say you want to manually override this, and that can be done as well. So when you're redistributing, you don't want the origin code to appear as question mark, you want it to appear as I, right? You want it that way, then you can do this. You just need to manually say set origin, sorry, you need to do this under the route map, not here, my bad. So where is my route map? My route map is here, right? I have already used the match statement. I just need to do set origin IGP, right? You do that. Now when you hit the do show IP BGP, takes a bit of time. It takes a bit of time for the changes to appear, but maybe let me clear the BGP routes. I always like to use the soft because it will just see the changes, right? So now if I do show IP BGP, yeah, you can see now the 7 route, right? It has changed from question mark to I, right? So this is an interesting mechanism. So what we learned, we have something called as origin code, which helps you understand if the route was learned either by redistribution or via, you know, the networks command. And if you want to manually override that kind of a functionality, right, you want, you want the routes to be um, injected via redistribution, and still the origin code you want it to be as I, you can do that as well. You have to just use the route map, and under the route map you have to do set origin as IGP. Okay, great. Now let's continue with the discussion, and what we'll do now is we'll do R3, R7 and R6, right? So we have an R3 here, we'll do R7 and R6. Okay. Okay, did we do R3 and R1? I'm not sure, let me see. Okay, never mind. So we'll do this and we'll see that later. So we'll do R3, R7 and R6, right? So we'll go to R3. Let's do enable show IP interface brief, right? That's what you got. Now you do configure router BGP and 300, right? Because we are on R3. My bad, sorry, wait, I think it should be 1000, my bad. Okay, so let's remove this, right? So it's supposed to be 1000, right? We're inside AS 1000. Great. Network command is 3.0, and the other one is obviously 33 with the mask. We're using /24. Let's go there. And the neighbor command, what neighbor? We are trying to form neighborship with R6 and R7, right? So it's going to be 192 1 dot, with R6 it is going to be 36.6, remote AS is going to be 600. With R7 it is going to be 37.7, and the remote AS is going to be my bad, remote AS is going to be 700. Okay, there you go. So we are done with R3. Let's go and do the same thing on, say, R7 now, or R6. Let's do this on R6. Right, on R6 we'll do the mechanism which I showed you earlier using this access list, right? So if you're just to make this, I just want to repeat this on this so that you get used to it, right? So let's say 6 network, right, and we're going to use obviously 0.255 because it is /8. Same thing, let's repeat for, let's say here 66. Makes sense? Now just need to change this to 0 because we have a different mask on this one, right? That's good. So we created the access list. Next, what do? We create a route map, right? Route map RC. match, what do we match? Match IP address 1 clearly. Set origin, we do set origin because you want it to appear as origin code as high over there, right? That's got. Now you do router BGP 600 because we are inside R6, and redistribute. What do you redistribute? The connected routes route map is RC. Okay, the neighbor command is still needed, so you need two neighbor commands, one for R3 and other one for R7. So it's going to be 192. One for R3, it is going to be what, 36.3, and remote AS is 1000, and the other side is we have 37, sorry, 67, right? You want a 67, and let's see, getting some error. Did we make a mistake? Let me check that. So 67 and 67 and 6, sorry, 67 and the other side is going to be 7, right? Remote AS is going to be obviously, oh okay, so the remote AS number is wrong, right? That's why I can see that error coming. Anyway, so this one remote AS is going to be 700, so this should be good, right? Let me remove this earlier command which I did. So remove that. Let me put this again. So it's 36.3, remote AS was supposed to be 1000. Okay, I had made a mistake over here, right? You can see it's coming up now, and as the other one come up as well. 36.3 has come up. We just need to see if 67.7 has come up. Okay, it would have not come up because I've still not done anything on, I've not done it on R7 yet, I guess, right? So what do we do here? Let's see, what do we already have? Show run section router, right? We have it between R1 and R4. Okay, we don't have the other two, so you need to create the neighborships here, right? So what we do is we go inside router BGP 700 and create the neighborship for these two guys, which is neighbor 192.1.37.37.3, right? Remote AS being 1000, right? You need to put the AS remote AS correctly, otherwise you will see those errors coming like earlier, right? For the R6 as well, we're going to do the same thing. Do it as 67.6 because that is R6. Remote AS is going to be what? Clearly 600. Okay, so now both the neighborships should come up anytime soon, and we will be able to see, yes, they have come up. Probably I'll go to my R6 now, clear the screen, and if I do show iBGP, right, you can see it has my networks, it has my R7, it has learned the 7 network, it has learned the 3 network, right? It has also learned the other networks, which is 1, 4 and stuff, right? We'll see that later, but this is what I wanted to show you, right? So we established, we configured BGP on R5, right? Whatever was on R5, R4, R7, R6, right? It was all your eBGP. Till now, whatever we did was everything was eBGP, right? We configured it on all the edge routers, right? We did it on R2, R1 and R3 inside this AS and all the other routers as well. So it was all eBGP, right? We did not do iBGP at all, right? How do you differentiate, how do you know it's a eBGP? When your remote AS is not same as your AS, right? So when you're doing this, when you're using the neighbor command, you're using remote AS. Remote AS is 1000, right? But you know that on R6 the AS is 600, right? So that's how the router understands that it is a eBGP, right? When the remote AS is not same as my local AS. Okay, great. So now let's dwell in. Let's look at probably one of the route here. Let's say the 4 route, right? What you see here is that we have two different paths to reach the 4 route. So where are we? We are on R6 over here, right? We are on R6, and you know, on R6 we are able to see that to reach my 4 route, it has to it has two different paths, right? One is through my R7 and the other one is through R3, right? So either you can go through R3, right? And maybe what is the other path, right? So it's through, right? So this is the one, right? So it okay, so through R3 is here, my bad, right? So you can go to you can go through R3, which means R3 is 1000, and then you come to 700 and then 400. So this is the path, right? From R6 you go to R3, R3 to R7, and then you reach here. Or the other path is 700 and 400, right? That's the AS. So you can go from R6, you can go to 700, then you go to 400, right? So there are two different paths to reach my 4 network, right? So so BGP gives you this flexibility. It gives you multiple paths, right, to reach to reach a particular destination, right? So you might wanna, I don't know, you might though this is like the shorter path, and you might wanna prefer this sometimes, maybe because they have faster links, right? Or maybe you have a contract regulation which says that no, you can't take this path, then you'll have to take the longer one, right? So we will see how we can kind of like engineer these routes and how we can engineer the router to take the routes which we want, right? So never allow BGP to do the decision on its own, right? Because then it won't be optimal at all. So you need to always decide it for BGP, using all the amazing benefits which you get out of it, like the attributes in this case, AS part to be more specific in this case. Okay, so yeah, coming back now, do you think the configuration is complete, right? Do you think there is like end-to-end connectivity in this topology? No. Why? Because AS 500, let's say AS 500 is not reachable from any of these ASs. Like if you look at R6 as well, see, you don't see the 5 network here, right? Because this AS is completely disconnected from these guys. Why? Because we don't have any kind of, we don't have IGP and iBGP here in my AS 1000. We have not configured anything of that sort, right? As a result of that, the 500 what's learned, right, it is learned only till R2, but from R2 it is not propagating, it is not entering, you know these ASs, right? So you have the neighbor relationship here between R5 and R2, and you have these neighbor relationships or the eBGP relationships between these edge routers. Okay, so now when we look at this topology, what is the best design? How do you know design, or how do you come up with the best design in such a scenario? So that's what we will be actually seeing now. Okay, a second.